Okay, let's go through how to do some work problems. We've got the equation up on top, work equals force times distance. We can see that right here. And this is a little bit new to us. These are some of the things that I used to write for you guys on top of the sheets, and now they're actually printed on the sheet. So labels for work, we have a joule. We actually have a second one, a Newton. I'm gonna put the little dot for a Newton times a meter, a joule or a Newton meter. Force is in newtons. And I think there we'll see it always as newtons. I don't think we'll see it as kilograms times meters per second squared. And here for distance, we will typically just see it as meters. And so there we've got that. And now something you've always just been doing on your own, you're isolating all three variables for the work equation. So isolating means we have to get it by itself. Well, right here, work is by itself. So work is equal to force times distance. But if I want to get F by itself, I'll slide over here, we'll do that. So if I'm trying to get F by itself, currently multiplying times D. So the opposite of multiplying times D is dividing by D. So if I divide on one side, I have to do that to the other. And so then my D's cancel, and I'm left with, so there F is by itself. I like to put the F on the other side. So I like to see it like this, work divided by distance. And so here, and then you guys find out, get D by itself. You guys solve that one on your own following the same logic. Again, that's stuff we've always been doing. It's just now it's actually printed on the sheet, and that's part of the homework that you have to do. I'll get these started for you, get them to a spot where you can take over and do them. Oops. Follow our same logic. Um, 800 newtons and 2.4 meters. Trying to find work. And from there, it would be similar to what we've seen in the past. So you guys can finish that one on your own. We've seen that before. Well, maybe we'll do that one just so we can see the labeling. Fill in the numbers, 800 newtons times 2.4 meters. I go to my calculator. $1,920. Oh, I should keep that just $1,920. And then newtons, I can't cancel that. Meters, I can't cancel that. And so there's Newton times a meter, and we see that as 1. And then our other option, of course, for work being this transfer of energy, 1,920 joules. If I go to number 3, uh, 400 joules, that would be work. That's our label for work. 200 kilograms, that's for mass. I don't see anywhere for that just yet. Distance is 16 meters. How much force did she use? So here's my question mark. Well, if I go back up here, we already solved for force. That's right here. That was the purpose of doing this. And so now that comes down there. There's our equation. We've already got it figured out. And if I look at this one, it looks like I don't need mass. And so this right here, I'm not going to need the 200 kilograms. So it's in there. I just don't need it. And I'm going to switch from the joules. I'm going to get rid of that. I'm going to switch to the Newton times a meter. Again, that longer label tends to help me get to the right answer in my, or the right label in my answer. And F equals, let's see here, F equals, that's going to be a 2, is that a 25, I think? And then the purpose of showing that longer label, my meters cancel. and there's my force of 25 newtons. And so you've got 4 more of those, all similar fashion. And then on this page, I think there's some conversions down on the bottom. Same thing, set up your fractions like we've been doing. That's nothing new. You've got your conversion. If I look at these, it says analyze the following diagrams. And number 1, determine what direction is the force being applied. Well, it looks like this guy's pushing a cart, so his force is going that way. So number 1, I'm just going to do that. The motion, the cart would also be moving forward. I'm going to go that way. Is work being done? Well, since the direction of the force and the direction of motion are in the same, and then you would just do similar to each one of those. Remember, if the direction of the force and the direction of motion are not in the same, then work is not being done on that object. We'd have to reanalyze and figure out where the work's being done. And then, like I said, set up the fractions, put your labels on them, just like we've done in the past for those. I still have a pretty good handful of people that aren't doing that, so make sure you're getting in the habit of showing me those fractions.